The sun doesn't just light up the solar system. It blows a constant wind of charged particles outward, and that wind eventually runs into a wall. The sun constantly releases a stream of charged particles called the solar wind, rushing outward in every direction at hundreds of miles per second, made up mostly of protons and electrons flung off the sun's outer atmosphere. That wind carves out a vast, invisible bubble around the entire solar system called the heliosphere, pushing back against the thin gas and dust that fills interstellar space between star systems. Every planet, moon, asteroid, and comet we know of orbits well within the protective reach of this bubble. Without it, harmful galactic radiation would strike the inner planets far more directly than it does today. As the solar wind travels farther from the sun, it thins out and gradually loses pressure, while the interstellar material pressing in from outside stays roughly constant, made up of gas and dust drifting through our region of the galaxy. Somewhere around 90 to 120 times Earth's distance from the sun, depending on how active the sun currently is, the two pressures roughly balance. That boundary is called the heliopause, and crossing it means leaving the sun's direct influence entirely and entering true interstellar space. Only 2 spacecraft have ever actually reached it. One crossed the heliopause in 2012, and a second followed in 2018, each confirming the crossing by detecting a sudden jump in surrounding plasma density and a matching drop in solar wind particles, exactly as scientists' models had predicted decades earlier. Beyond that point, NASA's IBEX mission has mapped the heliosphere's overall shape from right here at Earth, using energetic neutral particles, revealing something closer to a deflated croissant than the simple comet tail shape long assumed to trail behind the sun. Each spacecraft also detected a distinct jump in the surrounding magnetic field as it passed through, an unmistakable signature confirming it had truly left the sun's direct domain behind. The heliosphere does more than simply mark a boundary line in space. It also acts as a partial shield, deflecting a meaningful portion of the harmful cosmic radiation constantly drifting in from the rest of the galaxy before it ever reaches the inner planets. Studying exactly where and how that shield holds up under pressure tells scientists what conditions actually look like at the true edge of the sun's territory, and what any future spacecraft traveling beyond it will eventually have to face. NASA's New Horizons probe, which flew past Pluto in 2015, is now heading toward that same boundary too, though it remains years away from making its own crossing. Subscribe for more boundaries marking where our solar system ends.